Hello student, I am Professor Satyanarayan from Department of Mechanical Engineering, Christ University. Today we are going to discuss about basic thermodynamics. So, in basic thermodynamics there are two important laws. One is the first law of thermodynamics, which is conservation of energy. Next is second law of thermodynamics, which deals with the quality of energy as well as the direction of energy, the energy flow. Okay. So, in the first law of thermodynamics, energy is conserved. So, if you take a closed system, and this is the control volume, okay, and you have the heat getting into the system Q, and you have work out of the system W, okay, there is going to be change in the internal energy. So, therefore, the first law of thermodynamics states Q is equal to change in the internal energy plus work. This forms the basis of the first law of thermodynamics, right. Now, once we have clear with this, what happens in a flow system, how the first law changes with a flow system. Now, in a flow system, for example, let us take a turbine. Let us take a turbine. You have the steam entering the system, a fluid entering the system, and fluid going out of the system, and you have a shaft. Okay, and which delivers work. This also, let us assume that it is insulated and the control volume is, this is an open system. When we discussed the earlier example was for the closed system. This one is for the open system, where you have mass getting in the system, getting out of the system, energy getting into the system, getting out of the system. Okay. So, this is the control volume for an open system, clear. Now, so you have a set of mass getting in the system, okay. Let me call this 1, and they have getting exiting the system as 2, okay. So, if you want to apply first law of thermodynamics, okay, so what we do need to do is, for a turbine, the equation is dq by dm plus h1 plus v1 square by 2 plus z1g equal to h2 plus v2 square by 2 plus z2g, okay, plus dwx by dm. Now, for a turbine, what happens is, since it is insulated, so there is no transfer of energy. So, Q is 0, okay. So, therefore, this particular factor becomes 0, okay. Next thing is, if you take the elevations at the inlet and the outlet to be equal, okay, that is Z1 equal to Z2, therefore, this cancels out, okay. Now, if you assume the velocity at the inlet is equal to V2, okay, velocity at the outlet, then this factor becomes cancels out. Therefore, the work done by the turbine in a flow system is H1 minus H2, okay. That is how you apply first law of thermodynamics for an open system. Thank you.